everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this integral of cotangent of x over sine to the powers 205 x plus 1 all to the power 2. That's a bit tricky, but if you're watching this video, that won't be difficult for you anymore. So let's hope together and have fun. We know that cotangent of x is cos over sine. So we're going to have integral of cos of x dx over sine x times sine to the power 2 under 5x plus 1 squared. We know that the derivative of sine is cos and the derivative of cos is sine. Let's forget about the signs if it's negative or positive. We're gonna deal with that later. Okay, so if we let sine to be equal variable, the derivative of sine will produce cos. So why not do that? Why not? We can do. So let sine of x to be equal to t. The derivative of sine will be cos x dx. The derivative of t is 1, so will be dt. So now we can substitute back in our integral. We're going to have cos dx, it's dt, over, where there is sine is t, so t to the power 2 under 5 plus 1 squared. Okay, we can also write like this. We know that there is 1 here, dt. Now the question is, we have 1 here. Okay, perfect. Can we apply partial here? That's gonna be too much, that's gonna be complicated. And the problem here is not about being hard, it's being smart. So if we apply partial, that will take forever. But we're not gonna apply partial. So if we have the 1 here, what is it missing for this expression to be on top here? Why on top? Because we can simplify if it's on top, but it's not on top. What if I introduce t to the power 2 under 5 on top? What will happen? We'll change my expression. But not to change, what if I subtract? It goes back. Perfect. So here where there is 1, we can say it's t to the power 2 under 5 plus the 1 minus t to the power 2 under 5. Okay. Because if I cancel out, it's still 1. So this expression is similar to this one. So why not separating each one with the common denominator? So what will happen now? We're gonna have t to the power 2 under 5 plus 1 over t times t to the power 2 under 5 plus 1 squared dt minus integral t to the power 2 under 5 dt over t to the power 2 under 5 plus 1 times t outside. Okay, now this expression on top, it's similar to this expression. We can cancel out with the 2. So we will have integral dt over t times t to the power 2 under 5 plus 1 minus this t can cancel with the t to the power 2 under 5, so will be t to the power 2 under 4 over t to the power 2 under 5 plus 1. This is still squared. Okay. Yes. Now we have two integrals. I can call this as integral 1 and this as integral 2. Okay, perfect. Now let's solve first integral 1. We have integral 1. It is integral dt over t times t to the power 2 under 5 plus 1. Can we apply partial here? Yeah, but the thing is, just look, it will be complicated, it will be strange. So let's not do that. Sorry, but let's not do that. Okay, we can factorize t to the power 2 under 5. Can we? Okay, let's factorize then. There will be integral dt over t times factorizing t to the power 2 under 5 will be 1 plus 1 over t to the power 2 under 5. Okay, but 1 over t to the power 2 under 5 is the same as writing t to the power minus 205. Okay, and t times t to the power 2 under 5, same base, we can keep the base and add the exponent, which will be 206. And since it's 1 over t to the power 2 under 6, it's the same as writing on top t to the power minus 206 dt. Because this goes back, it's the same as 1 over t to the power 206, which comes here. Now, if we look, if we derivate our denominator, we get the numerator. So why not let? So we can let 1 plus t to the power minus 205 to be equal to, for example, m. Okay, derivative, we have minus 205 to the power t minus 206 dt equal dm. If we isolate this expression, then this negative 205 can come this side, dm. Right, because this expression we have on top. So integral 1 will be equal to integral, where there is this expression, it's this expression, minus 1 205 dm over this expression we set to be m, so it's going to be over m. This will be minus 1 over 205. Integral dm over m is ln of m. Okay, but what's the value of m? Is this expression. So that means integral 1 will be equal to minus 1 over 205 ln of 1 plus t to the power minus 205. So integral 1 will be minus 1 over 205 ln of 1 plus, what's the value of t? We let in the beginning to be sine x. So will be sine to the power minus 205 of x. Okay, so that is the value for integral 1. Now let's solve integral 2. What is going to happen? If we check in the integral 2, if we let the denominator, just the inner part, the expression inside the bracket, if we let this to be equal to a new variable, when we differentiate, since this is 2 under 5, will give us 2 under 4, because we know the power rules in differentiation decreases the power, while in integrations increases the power. Okay, so why not let the in expression to be, let's say, a, for example. It's not a problem. If we let them to be a, for example, we're going to have, for integral 2, we're going to have let t to the power 2 under 5 plus 1 to be a. Differentiating, this is 2 under 5, t to the power 2 under 4, dt equal to dA. Right. Okay, now, this is multiplying, can come this side dividing. It's going to be 1 over 2 under 5 dA. And then the integral will be t to the power 2 under 4 dt will be now 1 over 2 under 5 dA over, where it is t to the power 2 under 5 plus 1, we said it's a, so it's going to be a squared. This expression can go outside because it's a constant, 2 under 5. Right. And a to the power 2, it's the same as a to the power negative 2. So it will be a to the power negative 2 dA. Okay, so this is again power rule. So we're going to have this is equal to 1 over 2 under 5 times a to the power minus 1 over minus 1. What is the value of a? We said it's going to be minus 1 over 2 under 5 times t to the power 2 under 5 plus 1. But the value of t minus 1 over 2 under 5, the value of t is sine x, so it's going to be sine x to the power 2 under 5 plus 1. But the thing is, we were not given the problem in respects to a or t, that's why we substituted and we replaced it back. But what is our solution? Our solution, of course, will be integral 1 and integral 2, the solution combined together. So what is the solution of integral 1? It's this expression. It is, so therefore, the solution will be equal to minus 1 over 2 under 5 ln of 1 plus sine of minus 2 under 5x. We had minus there, the solution for integral 2. What is integral 2? It's this expression. It's a negative. With the negative here, will be positive. Plus minus 1 over 2 under 5 sine to the power 2 under 5x plus 1 plus c. So this is the solution of our given integral. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.